Hello and welcome to the Iterators and Generators section of this course. So in this section of the course we'll be learning the difference between iteration and generation. We'll get started with a brief presentation on just the overall ideas of iteration versus generation. So like I mentioned, here we're going to be discussing iteration and generation in Python and how to construct our own generators with the yield statement. So we've touched on this topic in the past when discussing the range function in Python 2 and the similar xrange function, with the difference between range and xrange was that the xrange was a generator. So let's talk about creating generators. We've learned how to create functions with a def and the return statement. What generator functions allow us to do is write a function that can send back a value and then later resume to pick up right where it left off. So this type of function is a generator in Python and allows us to generate a sequence of values over time. The main difference in syntax that you'll see is the use of a yield statement instead of a return statement. Otherwise, you'll see that a normal function that iterates versus a normal generator function will actually look really similar, the only difference being the return and the yield statement. So how do generators work? In most aspects, a generator function, like I said, appears super similar to a normal function. The main difference is when a generator function is compiled, they become an object that supports an iteration protocol. So that means when they're called in your code, they don't actually return a value and then exit. So you can think of range, just return the list and then exited. The generator functions will automatically suspend and resume their execution and state around the last point of value generation. And the main advantage here is that instead of having to compute an entire series of values up front, such as that entire range list, the generator functions can be suspended. And this feature is known as state suspension, and we'll explore that later on in this section of the course. So why use generators? Generators are best for calculating very large sets of results, particularly in calculations that involve loops themselves, in cases where we don't want to allocate the memory for all the results at the same time, just as I mentioned back in the range lecture. And like I mentioned, we noted before that a lot of the functions in the standard library that return lists in Python 2, such as range, have been modified to return generators in Python 3. Because generators are a better way of creating those objects. So let's go ahead and jump to the live code.